having introduced 5 different forces, including the 4 basic force and the spring force. Now this is the 6th force we're introducing, that's called buoyant force and Archimedes principle. The motion we're going to look at is called sink or float. So this is a special motion that's only in the fluid, not in the solid. Buoyant force, or we call Archimedes principle, we're going to introduce both the direction and the magnitude of the force that's pushing up an object in the fluid. And then we're going to follow up with an example. In one of the seas, people can actually float on top of water. You can read newspapers or magazines without any flotation devices. Okay, what is that place? Yes, it's the Dead Sea. And is it in New Jersey where there's a balloon festival where throughout the weekend there are all different kinds of activities and hundreds of balloons floating in the sky. So that's Hot Air Balloon Festival in New Jersey. And here is a homework for everybody who takes the class. There's a Walt Disney movie called 20,000 Leagues Under the Sea. It describes a submarine, how it works, and all the mechanisms. And what's really interesting is this is based on a book that's published years before the first submarine was even designed. As a matter of fact, when the first submarine was designed, it's named after the submarine in the book. So I want you to go find out what's the name of that special submarine in this science fiction movie. When an object is in a fluid, it's a liquid or gas, there is a force that always is there to push this object up. And the force is always pointing up, that's the direction. And the magnitude is equal to the weight of the fluid displaced by this object. In other words, if an object is totally or partially submerged, the volume underwater surface is V. And rho is the density of the fluid surrounding this object, and G is the gravitational acceleration. So the buoyant force equals to the density of the fluid multiplied by the volume, which is the mass of the fluid, times G, so that's the weight of the fluid, displaced by this object. For example, a 1,000 kilogram boat is floating. What is the volume underwater? This is also called water line. Apply buoyant force and Newton's second law. So net force equals the buoyant force minus mg, that equals to 0 because it's at rest. The volume equals to then the mass divided by the density of water. So it's 1,000 divided by 1,000, that's 10 cubic meters. That's the example. In summary, we introduced a new type of motion that's called sink or float in the fluid. We introduced the buoyant force, or we call Archimedes principle, both the direction and the magnitude. And also we followed up with an example.